All right, what's going on? We're going to factor by grouping. So I have a boatload of examples for you. I have about 6 examples, and they're all of varying difficulties and varying types of grouping. So we're going to go over some problems that maybe you haven't seen before, or maybe you have seen in the IXL, and I didn't tell you about them. So I guess we'll find out if you watch these videos or not. So here's the first example. Kind of. I'm just going to explain grouping a bit. So I think it's kind of confusing because a lot of times, we get to the step that's like, say you have something like, say you have something like 3 and then x plus 1, or this will be more like 3x, sorry, 3x times x plus 1 plus 2 times x plus 1. And then, teachers, including me, we do this thing where we're like, oh, well, this 3x and this 2, this makes up a factor. And then this x plus 1, this makes a factor. And a lot of people are like, how does this work? Where does this x plus 1 go? That's confusing. So let me see if I can shed some light on this. If we take a look at this over here, we have a times x plus b times x. If you were to factor a GCF out, you would factor x out. So you would take x out of both of them, and you'd be left with x times a plus b. So you could tell yourself right now, well, where did the x go? I had 2 x's up here, but now I only have 1. It's because you factored it out. You're doing the opposite of the distributive property. And now we have something here. We have a times, instead of x, it's x plus y. And b times, instead of x, it's x plus y. So what we can do is we can actually factor out a GCF, just like we did at the top. We can factor out x plus y. And this will leave us with x plus y on the outside. And then whatever is left inside is a plus b. So notice how, this is effectively the same thing as this. These are the same thing. They're just a different way to present the information. That's all. You're just factoring out the GCF, and the GCF for this top example happens to be x plus 1. This GCF for this more variable heavy example is going to be x plus y. So that's kind of maybe that makes more sense with grouping. Maybe it doesn't. I just wanted to show you that. All right, so now we're going to go to some actual examples. This is kind of a simple example. So we're going to factor this. How you do this is you take the GCF of the first pair. So I'm going to go ahead and do that. I can take out a 2, and I can take out an x squared. And what's left inside is going to be x minus 2. If you're confused on how to get this on the inside, you can see what they have in common and then divide both of the terms by what you're going to factor out. So, we're factoring out 2x squared. If I divide 2x cubed over 2x squared, I would just be left with x. If I divide 4x squared divided by 2x squared, I'm left with just 2. And for this one, I also have to find the GCF of these 2 terms. So this is going to be plus 3 times x minus 2. And now we can do that grouping step that we just talked about. So you can think of it either as these 2 making a term, 2x squared plus 3, and then this x minus 2 making a term. And this is the answer. Or you can think about it as taking these x minus 2's, factoring out the GCF, and the 2x squared plus 3 is what's left over. So either way works. But this is what we are left with, and this is our answer. So now let's go on to 4 more increasingly challenging examples. So here is another example. As you can see, this one's kind of interesting because it's an x to the 4th. You might not have seen that before, but let's find out what happens. So it's the same process. I am going to GCF the first part and GCF the second part. So the first part, I can take out an 8x cubed, and I'll be left with x plus 2 on the inside. And then I can take out a negative 1, and I'm left with x plus 2 on the inside as well. So it's the same thing. I can factor out the x plus 2, that's my GCF. So let's see, let's do this in a different color. Maybe I can show you this way. Factoring out the x plus 2, so that will leave you with x plus 2 on the outside. What's left inside is 8x cubed minus 1. And those of you that got this far, that's not bad. This was already tricky with the x cubed, but we're not done yet. We have to keep factoring. So those of you with a sharp eye might have seen that 8x cubed minus 1 is a difference of cubes, what we learned in the last video. So what we can do is we can factor this again. We can factor this farther. So that's exactly what I'm going to do. This can be written as 2x everything cubed minus 1 cubed. And then I can use the difference of cubes formula, which is going to be 2x minus 1. It's the same sign, times 4x squared, the opposite sign, plus. This is going to be 2x and then plus 1. And this is going to be your completely factored form of this polynomial. So we have a few more examples, so let's keep going. Alright, so this one looks crazy, but I guarantee you it's the same thing. So let's take a look. Alright, so you're just going to GCF the first pair and GCF the second pair. And for all these examples, I would like, if you're watching this, to try these on your own before you watch me do the example. But anyways, go ahead. So yeah, right now I'm going to go ahead and GCF the first pair, and I'm going to be taking out an xy squared, and I'm going to be left with 2y plus 1 on the inside. So I'm just taking out what they have in common. They have an x in common, and they have 2 y's in common. So that's why I can take out an xy squared. And then here I'm going to take out a negative 3. Sorry, not just negative 3, a negative 3z. And I'm going to be left with 2y plus 1. So it's the same thing. You're just going to bring these down and make a term, xy squared minus 3z. And this other one is going to make a term as well, 2y plus 1. And there is your factored form. Two lovely factors just made for you. Alright, we got two more examples. It's already almost 8 minutes long, oh my gosh. But I can't not do these examples, they're too fun. So check this one out. This one you're like, what the heck, Mr. Lee? Come on, you're trolling me. And I would say to you, yes, I am. But we're going to do this problem anyways, because I think it's fun. So you might be like, how is this even related to grouping, or what is going on? So in the previous examples, we've been making two groups of 2. Right, so we have, this is the group 1, this first pair, and this is group 2, the second pair. Well, now we have 6 terms. So we have a couple options. We could either make 3 groups of 2. So we could group it like the first 2, the second pair, and the third pair. And we can see if that works out. Or we can group them in 2 groups of 3. So the first 3 and the second 3. Okay. So if you take a look, you can see pretty quickly that grouping them in groups of 2 won't work, but grouping them in groups of 3 will work. So let's go ahead and try that. I'm going to try groups of 3. And now I'm just going to GCF the first 3. So I can actually take out an x cubed here. And I'm going to be left with x squared minus 3x plus 2. So you can see this is already going to be interesting at the end there, if you have a keen eye. And then here I can actually factor out a 27. So I'm going to have plus 27 parentheses x squared minus 3x plus 2. And wow, this just works out so perfectly. I wonder who wrote this beautiful question. It totally wasn't me at all. And now we can do the same grouping step. We can take x cubed and plus 27, make that a term. And then this x squared minus 3x plus 2 will also be a term. Remember, you can also think about it as factoring out the greatest common factor that greatest common factor happens to be x squared minus 3x plus 2. So I'm just going to do it this way. I'll have x cubed plus 27, and then x squared minus 3x plus 2. And if you have a keen eye, you will notice that both of these are indeed factorable. So I can factor x cubed plus 27 because that's a sum of cubes. And x squared minus 3x plus 2, that's a quadratic, that's a normal quadratic that's factorable. So I'm going to go ahead and do that. So 27 is 3 squared, so I'm going to have x plus 3. And then times x squared, the opposite sign is going to be minus, and it's going to be 3x plus 9. So 9 is b squared. And then times, I can factor this. This is going to be x minus 2 times x minus 1. So this is our factored form. And we have had a lovely time doing it. All right, we got one more example. I know this video is way too long, but we got one more example. All right, and here they are. Here it is. So now you must be like, okay, Mr. Lee, I thought this was math class, not English class. Why there's so many letters on my screen? There's only 2 numbers, and they're small numbers. They're exponents. Well, I would say to you, that's pretty funny. But here we are with letters, more letters than numbers. Welcome to math. It's the same thing, though. All you have to do, you just have to GCF the first pair and the second pair, and then factor, So I'm going to GCF the first part, and I'm going to GCF x. Inside I have y squared minus 1. I'm going to GCF z, so z on the outside and y squared minus 1. And these two make a term, so I have x plus z. And then times y squared minus 1. You got a difference of 2 squares this, so you're going to end up with x plus z times y minus 1 times y plus 1. There is your answer. And I know this is a long video, so if you watch the whole thing, thank you. Yeah, it's going to be it. So the next video is going to be over rational root theorem, and if you're watching this, you're probably going to watch that one. So I'll see you there.